Okay, so we're going to look at gradient functions and how we deal with gradient functions. So we're going to start off what we did. We're going to start off with y is equal to x squared. That's our function. And we're going to start at this point here where we have x is -2, and we know on the graph that the y value is 4, but that's not really all that significant. What we want to know is if we draw a tangent to that point, we want to know basically what the gradient function for that tangent, what the gradient is for that tangent drawn at that line. We know it's negative. This is important. We know it's negative. And so we want to we can estimate what the gradient is, but even better, we could go to our graphing calculator and we could get the tangent drawn accurately and come up with exactly what the gradient of the tangent is at that point. And when we do that, we find that we get a gradient that is -4. So what we've done is we've taken this point, we've identified that this is the point that we want to deal with right here, and then we've discovered that the actual gradient of that tangent line that we draw at that point is -4. Now we're going to move the point along, and we'll go down to -1. We can figure out what the point is at -1. And again, what we do is we simply take that point and draw a tangent to that point, which is what our calculator does, and we have to estimate it, so we can't get an exact value, but we can estimate it. And again, we can go to our calculator and we can say, well, what is the gradient of the tangent at that point? Again, it's negative, and then we have to get the exact point. And the exact point, at that point, the exact value for the gradient for that tangent line is -2, if we worked it out, and our calculator will give us a straight line at that point with the gradient of -2. And that's at that point, -1 and 1. And then we continue along, and we draw a gradient or a tangent to the point 0, 0. And it's a straight horizontal line, which we know has a gradient of 0 at that point. So it's negative, 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 negative all along here, all along this part of the branch. Then it's 0. And then as we start to go up to the other side, all the gradients of the tangents are positive, 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 positive. So if we then move our point, let's say we can move it to 1, and we want to know what the gradient is for that point there. And if we use our calculators, we find that the gradient of the tangent line to that point, that gradient is 1. And then we move it along. Let's do 2, because that's what we did on our thing. And again, if we work that out, we get 2. Now what happens is, all of these points that we've been plotting, points, and so on, and we can do 3 and 9 if we want, 3 and 6, sorry, and -2 and -4, these create a line, and this line that we're creating here through the parabola is called our gradient function. That's a line that represents all the gradients of the tangent lines that we draw. And basically, when the gradients are negative, this line here must be below the x-axis. Then it goes through the turning point of the parabola where the gradient is 0. And then afterwards, where the gradients along here are all positive, then the graph, the straight line graph, must be positive. So this, equivalent to this, must reflect that we have here all positive gradients, so it must be above the line. So really, a parabola, the gradient function is always going to be a straight line. Where the tangents, the gradients of the tangents are negative, it's going to be below the line, then it's going to hit the turning point, and then it's going to be above the line.